Welcome back. This is section 7.4, and today we are talking about the double and half angle formulas. So, of course, on your formula sheet, there are tons of trig identities. There's product to sum to product, power reducing, all kinds of identities that we didn't talk about in 7.1 and 7.2. The other two main ones that we are going to talk about this unit are obviously the double angle formulas and the half angle formulas. Where these come from is actually really interesting. I don't want to make this video much longer than it needs to be to encourage you to actually watch this. So I will save that for class or for after school sometime. But I'm not going to derive them for you right now. Instead, I'm going to show you how we use them. So you don't have to memorize these. These are on your reference sheet, but you do have to understand how to use them. And that is our learning target for this section, to be able to evaluate trig functions of 2x or 1/2 x using the double and half angle formulas. So we'll start with the double angle formulas. These allow us to find the values of trig functions at 2 theta from their value at 1 theta. So if I know the sine of theta equals some value, then I can use the double angle formula to find the sine of 2 theta based on that value. So let's look at example 1 here. If the cosine of x equals -2/3 and x is in quadrant 2, find cosine of 2x and sine of 2x. So this is very reminiscent of section 5.4 when we first talked about trig and being able to set up a triangle or find x, y, and r for these sine functions or for these trig functions. Cosine we know is x over r, and here we're told that that's -2/3. So I need to find x, y, and r. I know that r cannot be negative, so r here has to be +3, which means x is -2. And we find y using the formula r squared equals x squared plus y squared. That's just the Pythagorean theorem based on this triangle in the coordinate plane. R is 3, so we have 3 squared equals -2 squared plus y squared. If we solve for y, we get y equals plus or minus the square root of 5. And so now we have to look at the other piece of information we were given. X is in quadrant 2, or in other words, the angle. I know it's a little confusing. I'm talking about an x value and then the angle value x. But the angle is in quadrant 2. And in quadrant 2, right here, y is positive. So we are looking at positive square root of 5. Okay. So same steps as before. And so now I can find sine of x. Sine of x is y over r, or square root of 5/3. Now that I know those two things, I have enough information to look at my double angle formulas here and here. So I want the sine of 2x. Sine of 2x based on the double angle formula is 2 times the sine of x times the cosine of x. 2 times sine of x we just found, square root of 5/3. Cosine of x we were given, -2/3. Multiply all of that together and we get -4 square root of 5/9. So the sine of 2x, whatever that x value is, whatever that angle is -4 times the square root of 5/9. Similarly, cosine of 2x, we have 3 different choices here. Choose whichever one you'd like. I'm just going to do 2 times cosine squared minus 1. 2 times -2/3 squared minus 1. Simplify all of that and we get -1/9. And that's it. So really, that's all there is to that. Understanding section 5.4, how we go about setting this up, how we find the trig function values for just the 1 times the angle itself, And then we can plug all of that into the double angle formulas to give us the trig function values for the angle doubled. Go ahead and try example 2 yourself. And we're going to practice this a bunch more in class. But for now, I'm going to move on to the half angle formulas. So these allow us to find the values of the trig functions at 1/2 theta based on their value at 1 theta. So these are the half angle identities, the half angle formulas. Again, I'm going to skip the derivation for now. We can talk about those later on. But basically, we use them just like we just used the double angle identities, or the double angle formulas. Find the exact value of sine of 22.5 degrees. Sine of 22.5 degrees. This requires us to be able to see what is 22.5 half of. Right? Because the half angle formulas are going to give me the value at half of an angle if I know their value at an angle. In other words, this is the sine of something divided by 2, and hopefully you see that this is the sine of 45 divided by 2 degrees, right? 22.5 is 45 over 2. So now we can think of this as sine of x over 2, which means I can use my half angle identity. So that's the sine of, or I'm sorry, not the sine of, that is plus or minus the square root of 1 minus cosine of x over 2, and x is 45 degrees, right here. So that's plus or minus the square root of 1 minus cosine of 45 degrees over 2, plus or minus 1 minus the cosine of 45 degrees is the square root of 2 over 2, all over 2. And from here, it's just a bunch of algebra. Subtract 1 minus the square root of 2 over 2, 2 minus the square root of 2 over 2 over 2. It's the same as dividing by that 2 is the same as multiplying by 1/2. Whoops, I'm not sure why I did 2 plus or minuses there. So multiplying by 1/2 gives me that, which is plus or minus the square root of 2 minus the square root of 2 over the square root of 4, which is 2. We're going to go through that algebra a little more step by step during class, since I know how much some of us struggle with step-by-step algebra. Anyway. And our last step is to choose the plus or the minus. So sine of 22.5 degrees, that means I'm in quadrant 1, so it's positive. So my answer is positive, square root of 2 minus square root of 2 over 2. We can check this. If I plug that expression into my calculator, I will get the exact same answer as if I did sine of 22.5 degrees in my calculator. This is the exact, precise answer for that. So this, aside from plugging into the formula, really just hinged on us being able to recognize that 22.5 degrees is 45 over 2. So if I asked you what's the sine of 15 degrees, you should be able to recognize that that is really the sine of 30 over 2 degrees. And then we can use a half angle identity to solve for the exact value. Example 4 is going to work just like the example we did for the double angle formula. So I'm given sine of x equals 2 over 5. Sine of x we know is y over r. So that means y is 2, r is 5. Using my formula, I will get x equals plus or minus the square root of 21. And we know that the angle is in quadrant 2, which means x is negative. So x is negative square root of 21. So from there, cosine of x equals x over r, which is negative square root of 21 over 5. And then tangent of, right, I'm solving for tangent of x over 2. Tangent of x over 2, looking at my formulas up here, there are two of them. You can choose either one. I'm going to do 1 minus cosine of x over sine of x. 1 minus cosine of x is negative square root of 21 over 5. Sine of x is 2 over 5. And then it's algebra. 1 plus square root of 21 over 5 over 2 over 5. Add the numerator, I need a common denominator. 5 plus square root of 21 over 5. Divide by a fraction is the same as multiplying by the reciprocal. So my answer ends up being, the exact value is 5 plus square root of 21 over 2. And we don't even need to know the angle there. We can get our answer that way. So we're going to practice this a lot in class, but really this was just about showing you how we can use these double and half angle identities and exposing you to the kinds of questions that you might be asked about these. So go ahead, bring your questions to me, and we will talk about this more in class. Spend a whole day practicing it before I give you any kind of a quiz. So have an excellent day, and thank you so much.